Okay. So our first speaker in the final session is Nigel Elliot from Mentor, a Siemens business, a gold sponsor. He's technical director of Mentor Europe Digital Design and Verification. His talk is on verification productivity with portable stimulus. Nigel heads up Mentor's European AE team focused on deploying functional verification tools and methodologies. He has been Mentor for 25 years and a number of technical roles, all relating to functional verification. Prior to joining Mentor, he worked as a digital and design engineer at telecoms companies such as GPT and Motorola. And I'll hand over to Nigel.
Okay. Thanks, Mike. So this session I'm going to be talking about portable stimulus, the new standard coming out from Accelera. I think a number of people have mentioned it this morning. So basically I'll be going into what it is, what the motivation is, why it's needed, and some of the benefits that it can provide. So I can get this to go. So there we go. Okay, so Mentor sponsors a survey that's done by Wilson Research on a sort of every 2 year. I think there's another one coming out at this DAC. And one of the things that we've been tracking is the use of embedded processors in designs, and we've consistently seen that grow. So for ASIC IC, nearly 3/4 of designs contain at least one embedded processor. For FPGAs, it's slightly behind that, but still growing. So that basically means software is an integral part of these designs functions. And so you can't just look at it from a hardware perspective. So if we look at the approaches that the industry has adopted for verification, we've seen widespread adoption of UVM. I think, again, the Wilson Research survey shows this at a sort of peaking out now, flattening out, about sort of 3/4 of all designs using UVM for block level verification, and it's very well done. It's very well suited to that. The use model for this is obviously at a block level. You're trying to model the real world and the functionality of surrounding IP for that particular IP under test. And that's great. Works very well, coverage driven, well established. The challenge is, as we move to either subsystem or full system, how we actually bring the work that we do at a block level into that level of testing. In particular, in an SoC where we have a CPU involved, suddenly the software execution on that CPU becomes a critical part of the verification and validation of that design. But we still want to use the block level agents, VIP, whatever you want to call them, either to drive primary interfaces or to do checking, coverage collection, etc., but in the context of the higher design. So this has been a challenge because UVM doesn't really lend itself to software verification. UVM is really very hardware centric in its capabilities. So what we're looking for, what would be ideal, is we have a mechanism that actually allows us to capture the intent of verification at a block level, and as we integrate into different levels of test, reuse that intent without having to go and rewrite it just because we moved from UVM to C++. So this is what's driven the development of portable stimulus. So the base technology around portable stimulus has been around for quite some time. Mentor acquired a company called Lighthouse Design more than a decade ago. And we donated the rule syntax from the InFact tool to Accelera, which formed the basis of the DSL implementation for PSS. There have been some early adopter LRMs effectively released, and 1.0 release of the PSS standard is scheduled for DAC, which is in 2 weeks' time. So this will become a live Accelera standard supported by Cadence, Brecker, who you'll hear from later, and others. So what is portable stimulus? The first thing I should say, actually, there's a bit of contention about the name. Actually, this isn't just about stimulus. It's actually about verification intent, and actually incorporates not just stimulus, but coverage, constraints, etc. So it's broader than just stimulus. It's focused on scenario level interactions. So if you're familiar with UVM, think about virtual sequences. Think about coordinating what's happening on multiple interfaces, or coordinating what's happening with multiple IPs, and being able to easily capture constraints that actually allow those to interact. And that's actually the key area that the portable stimulus is being aimed at. What it's not a single force level of abstraction, so you can write PSS down a very detailed level or be very abstract. It's not a replacement for things like UVM. So PSS will layer on top of UVM test benches. It will allow you to drive embedded software. So it's actually an additional layer. You still will need things to wiggle pins. That's probably your UVM agent or whatever. And the goal is to have a single representation which you can then target to multiple engines at multiple points during the verification process, from IP level simulation through subsystem, full system on emulation, FPGA prototyping, etc. So this is really what the expected flow will be. PSS actually defines two syntaxes which are fully compatible. DSL, which is the domain-specific language, and C++ library. Basically, why are there the two? Because depending on who's capturing the test, if it's more a hardware engineer familiar with System Verilog, they're probably going to write in DSL, because actually it has a number of elements that are similar to System Verilog. If it's an embedded software engineer, they're probably going to want to write in C++. And we should be able to actually mix and match the two. But basically, the semantics of both are identical. Having got a model defined, the tool will actually create a scenario model and also evaluate the constraints to actually create the solved model. This can be done at compile time, so you basically create it before you run the test, or it can be done at runtime, in which case this is happening while you're running the test. Both models should be supported. So if we look at the main building blocks of the PSS stimulus model, we have actions, which basically consist of an actual something that's implemented in the target environment, like it's a DMA transfer or sending a packet or whatever. Actions require data flow. So the two fundamental types of data flow are streaming data, e.g. for a streaming data output needs a streaming data consumer, otherwise you lose it. If it's buffered, it's persistent until it's read. So there's two types of data flow. And then the concept of resources. So if you have limited resources, things like DMA channels or CPUs or whatever, that could actually only be one at a time, you can define that in the PSS model, which effectively become constraints to the scenarios that are created. So if you've got if you define a scenario that requires 2 DMAs to be going concurrently and you have 1 DMA channel, that's not going to work, and you will have to actually do those sequentially as opposed to in parallel. So actions are modular. So what this means is that they either can map to a specific implementation, or they can actually be hierarchical, and so they can be decomposed into additional actions. And then a scenario is created by creating a valid flow through this sort of graph. Okay. The tool will take account of any data flow constraints, any resource constraints, and basically any scheduling constraints to actually come up with the scenario. Coverage. If we look at constrained random, some of the issues with constrained random is we only know what coverage we get after we've run the simulation. And if we keep running simulations, we may or may not hit the coverage points that we're after. And generally what we then do is use verification management to try and extract the useful seeds and actually throw away all the other tests which we've run, which effectively have been useless cycles. Portable stimulus allows us to define these scenario flows, but this is very explicit. What PSS also allows us to do is actually to do partial specifications. So we're basically saying, if I need to do B, and B requires a particular data input, I don't need to specify A if A is the only thing that can produce that data. So I only need to specify the things that I actually care about. I don't need to specify everything, which is basically like a directed test. If you specify everything, it's like a directed test. If you only specify the core intent that is important, effectively a PSS tool will be able to fill in the implementations. So this basically means as long as the data type, so here we've got a buffer match, so I'm looking for a buffer output that maps to the B action buffer input. I could have another action which also produces the correct data type, in which case the PSS tool will create a scenario with either of those actions in place. Likewise, if we're doing streaming, if it's streaming, you need both a producer and a consumer in order to work. So the tool will map those. And again, if you have multiple variants, then it will take account of those. So basically, this is how you can come up with some very sophisticated scenarios automatically generated by the tool without you having to explicitly define every particular combination. So back to functional coverage. Functional coverage in PSS is a constraint. So basically, what the tool will do will produce stimulus to hit the coverage. So so we basically will get to coverage in the quickest possible time. And just wrapping up quickly here. So Mentor has been a very active contributor to the PSS standard. We've had a graph-based tool in terms of InFact for a number of years with a lot of complete sort of results and successes, and yeah, I'm running massively over time. I would, if you want to know more, have a look at the Verification Academy. There's a whole section on Verification Academy about portable stimulus, and yeah, thank you.
Thanks, Nigel. Yeah, sorry, you were restricted to 15 minutes. Yeah, I must personally say as well, I'm very interested in PSS. I think PSS is the next big wave of verification innovation, and we're partnering with Mentor, TDS, and we're also partnering with Cadence and Brecker as well. So we're all over PSS. I think it's going to be quite revolutionary in the way we do our SOC verification. There's a LinkedIn group as well. There's a good LinkedIn group called, if you look up Portable Test